Okay, so moving right along, we want an integral expression. All right, so here's the first one of the other kind. We have the limit expression, and we have to turn this into an integral. So first we need delta x, and we can see that's right there. That's equal to 2 over n. Now, we want the a plus delta xk, or you're looking for the 2 over nk term. And so there it is, 2 over nk term. And there's no a in front, so a must be equal to 0. There is no constant in front. So if I'm sorry, it's not 2n up there, it's 2 over n. Getting ahead of myself there. 2 over n. Come on. So, okay, that means if a is 0, so b minus a has to be 2. So that means b is equal to 2 if a is 0. So I know my integral is from 0 to 2. This is my x, right, my xk. So just put an x in there instead of 2 over nk. So this would be x squared plus 3 dx. So that way is even easier to write. Okay, so then go look for that problem. You should get here 0 to 2 of x squared plus 3 dx. X squared plus 3 dx, just checking. So now we want to do another integral expression. See, you're going to get good at these. First of all, by the way, they're all pretty similar in the answers. I did that on purpose, so it wouldn't be obvious that you had to actually know how to do this. Okay, so let's start out with delta x. Again, delta x is 2 over n. And now we're looking for the 2 over n term. Now look, here's the 2 over n term, and it has a 3. So that means it's plus 3. That means a has to be 3. So a is 3. So if b minus a has to be 2, b minus 3 has to be 2, then b has to be 5. So I already know my integral is from a, which is 3, to b, which is 5. And this is my xk term. So you can tell it's squared and then added 1. So this is x squared plus 1 dx. All right, number 6. Oh, did I mess that up? Was that a square root? Look, I just didn't even pay attention to that square root there. So go back and make sure you have that square root. All right, number 6. Going back to the limit one now, so back and forth. So let's see, delta x is going to be 5 minus 1 or 4, so 4 over n. A is 1, right? Throws this number right here. So if I want to do a plus delta x k, that's 1 plus 4 over nk, and that's going to be my x term that I put into that x right there. So I would write the limit as n goes to infinity of the sum of k equals 1 to n of the ln, and then 2 times that right there, 1 plus 4 over nk, okay, and still in the ln, minus 1, okay, and then times 4 over n. So we can simplify this. Limit as n goes to infinity of k equals 1 to n of ln of 2 plus 8 over nk minus 1, and then times 4 over n. So wait one more step. Limit as n goes to infinity of the sum of k equals 1 to n of the ln, combine this, of 8 over nk plus 1, all times 4 over n. So there's your limit equation, your limit equal. All right, One more I think we can fit in here, number 7. Should have gotten that for 7. So we want to limit again. All right, so delta x is going to be 4 over n. A is 3. So my inside term will be a plus 4 over nk, or 3 plus 4 over nk. This is what gets put into the x. Okay, and so we can go the limit as n goes to infinity of k equals 1 to n of x squared, so that's 3 plus 4 over nk, quantity squared, minus 8. And then that is times 4 over n. And they're going to make us do this out to find the right answer. N goes to infinity of k equals 1 to n of, okay, let's FOIL this. That would be 9 plus 12 and 12, so 24 over nk, plus 16 over n squared k squared. And then we take away 8 and multiply that by 4 over n. So one more simplification step here. Limit as n goes to infinity, k equals 1, the sum of k equals 1 to n of, let's put it in order, 16 over n squared k squared plus 24 over nk plus 1, all times 4 over n. So there we go. That was number, what are we on, 7? Yeah. Okay, next video for the rest.